right, so here's what I would like you to do to get started for the day. Here I am on the camera now. Before we get started with our new section, I just want to do a quick review problem. And I would like you to do this. I would like you to just do this subtraction problem. 2 over x minus 3 minus 3 over x plus 3. Okay, we did a bunch of problems like this in class. There's a bunch on the homework. This is what we talked about last time. All right, so what I asked you to do is to subtract these two things, these two fractions that we have. So the process that we went over a whole bunch of times in class started like this. First thing you have to do is figure out what the least common denominator is. Least common denominator always follows this. You take one of every factor you see, and then if there's powers, you take the highest power. So help me out here. What is my common denominator of these two fractions? I need an x plus 3 for sure. X minus 3, those are different things. Remember, we don't just take the x, okay? Because this x is attached to the 3 by a plus, they go together now. Same thing for the subtraction. So you need both. Then the second thing I recommended you do after you figure out the common denominator, the way we use that here is that's going to become the denominator of both fractions. Okay, so I'm going to change both fractions into fractions with that denominator. And so what the question we then asked over and over is, what do I do to this denominator to make it look like this? And the answer is multiply by x plus 3. And so what I have now is 2 times x or 2x, 2 times 3 or plus 6. When there was a minus sign here for subtraction, there's other ways you can handle this. What I recommended is that you just treat this as a negative in front of a 3 and distribute a negative 3. So now, what do I have to do to this denominator to make it look like this? Well, that's an x minus 3. I need that. And so I have a negative 3 times x is negative 3x. A negative 3 times a negative 3 is plus 9. And last but not least, now I combine my like terms. Bless you. I've got 2x minus 3x, that's negative x. I've got 6 and 9, that's 15. That does not factor at all, so we are done with this problem. The reason I wanted to start there is because in the section we're going to do today, which is section 6.5, we're just going to do this one section. We're going to do as many problems in this section as time allows. This is probably the one of the top 2 or 3 most commonly ways you're going to use rational expressions when you go to college algebra. What we are going to do is we are going to solve rational equations. So I'm going to write down a rational equation for you. And we're going to note the difference because the most common mistake students make on the test is confusing what I do in that situation and in this present situation. And I want to show you what to look for. So here is an equation. This will be one that we solve in a little while when we get a little bit of experience. So it's 2 over x minus 3 minus 3 over x plus 3 equals 12 over x squared minus 9. So the difference here is this, because notice I intentionally used fractions that look similar. Okay, we've got the same 2 fractions here as right here, but the difference is this has an equal sign. That makes that thing right there an equation. Our very first day of class together, long, long ago, fairly blurry memory in your brain right now, I'm sure. But our first day of class together, I did this same thing when we started talking about equations. For equations, we solve equations. We come up with a value. We're going to put it in little squigglies. The reason we're able to solve is because we have an equal sign. So what we're going to do with this is going to be different than what we do here. This, since there was no equal sign, this is an expression. We can manipulate expressions and make them look different. Okay. But what we did here with this expression is we took 2 fractions and we smushed them together to make 1 fraction. So please note the difference. You do not solve expressions. There's no equal sign here. You cannot come up with a value. So please don't do that. That's something, sometimes students, I think you just get in the zone and you do the wrong thing in the wrong situation. I don't want you to lose points when you don't have to. Okay, expressions, we're taking 2 fractions, we're simplifying, we're making it into 1. Equations, we're going to solve, and that's the topic today. So I'm going to erase this problem that we did as our warm-up, our review of something we did in the past. And now here we go. The instructions for everything we do today is going to be this. We are going to solve these equations. So here's the first equation. I'm going to do this one, and then I've got several you're going to do, and then I'm going to do that equation right there, and then you'll have several that you do. So here we go. We've got 2 over x minus 3 over 2 is equal to 7 over 2x. We're going to solve this. We're going to come up with values for x. What number or numbers work to make this a true statement? That's our goal, as has been our goal anytime we've solved anything this semester. For the first time, we have x's that are in the denominator. Okay, so that's the challenge here. So what we're going to do is, again, we're going to find the common denominator, but we're going to do something different. With the expression that I just erased, we took the common denominator and we made that the new denominator to my fractions, so I could smush them together. But now, since I have this equal sign, that changes everything. What we're going to do is we're going to find the least common denominator. And the reason we're going to do that is we are going to do what's called clear the fractions. I want to have an equation that has no fractions. Because I know none of us like fractions anyway. So we're going to clear the fractions. And the way you do that, the process is once you find the least common denominator, you are going to multiply every term by the least common denominator. So we're doing something different with the common denominator than we did when we were combining our expressions together. So our first few problems, we're going to start off with denominators that are monomials, the simpler, okay, simple doesn't mean easy, but the simpler situation when my denominators are monomials. So looking over there, what factors do I need for my least common denominator? I need a what? I need a 2 and an x. That's it. I don't see anything else. I see a 2, I see an x. So I need one of each. Remember how you find the common denominator? You need one of every factor you see. And if there's powers, you take the highest power. Okay, so here it was just one of every factor we see. There's a 2 there, there's an x there. So the common denominator is 2x. So now what I'm going to do with the 2x is I'm going to multiply every term by the least common denominator. Here goes. Each of these fractions is a separate term. Terms are the things separated by the pluses and the minus signs. So here goes. I'm going to multiply this one by 2x. I'm going to put it over 1 so I know I'm multiplying the right thing. With the 3 halves here, I'm going to squeeze in a 2x over 1. And then on the other side of the equal sign, I'm going to multiply that by 2x over 1. Notice I've got 3 of them. I have 3 terms. I've got 3 2x's. At the end of this next step, once I'm done, I should have no more fractions. Okay? If you're using the least common denominator, or really, math secret, you can use any common denominator. Okay, so if you use a number that's too big, that's fine. It's not going to affect you at all. When you're done multiplying by the common denominator, you should have no more fractions. Well, let's see if we did it. Here's my first one. I multiply by 2x. This is 2 over x. What cancels between these two things? Only one of the things you said is the right answer. These 2's are both in the numerator. They're not going to cancel. Remember, when we talked about canceling things the very first day, we cancel when there's something in the numerator, something in the denominator. That's exactly the same. What is in the numerator and the denominator between these two fractions? That's exactly the same. The x. So I can cancel this x with that x right there. And then what's left? 2 times 2. What's 2 times 2? 4. It's not a fraction. Okay, it's 4. It's 10. Minus the next pair. Remember, when we cancel something in the numerator with something in the denominator, what cancels between these two things right here? The 2 does. Okay, there's a 2 here in the denominator. I can cancel it with this 2 in the numerator. And so now what's left? 3 times x. Here's my equal sign. So I'll write it right here. So I'm just going to draw a little arrow. My equal sign stays where it is. On the other side of the equal sign, I've got 7 over 2x. I'm multiplying by the common denominator, which is 2x. What cancels between these two things? The 2 and the x, both of them do. They're both there. So the 2 goes, see you later 2. And then the x goes. See you later, x. And all that's left then is 7. So that's the big deal, and that's hard, okay? So I understand this is the difficult thing. So I'm trying to go slow. If you have any question at all, please ask me. You're going to use this when you take college algebra. I promise you. Okay, and I don't have, when you take college algebra, I'll review this, but we fly through it. Okay, so now's the time to learn this and get good at this. Okay, because we're going to do all sorts of things with a whole chapter on rational expressions and graphing them and finding domains of them and doing all sorts of great things. Okay, it's going to be so much fun. Now that you get to here, this should be familiar. Okay, we've been doing this since the first day of class. I'm going to solve this for x, but remind me of the steps. What's the first thing that I have to do here? Okay. Yeah, I got to bring the 4 over to that side. I'm going to subtract it. So I'm going to subtract 4 from both sides. There it is. 4 minus 4 on the left side cancels, and I have negative 3x. My equal sign just keeps dropping down. 7 minus 4 is 3. What's the second and final step to finally solve this equation? Beautiful, well said. Divide both sides by negative 3. So on the left side, I have 1x, which is what I want. On the right side, 3 divided by negative 3 is negative 1. Now, there'll be something else I have to do with this answer in a little while, but for right now, this is done. All good. And so I'm just going to put in some squigglies. There we go. So here's a problem for you. It's essentially the same sort of thing. Okay, I'm going to leave this one up here. You have it in your notes. You can follow along. So what I would like you to do is this. Solve this equation right here. We've got 1 over 3x minus 3 over 4x. And that equals 1/3. Just to make sure we're working in the same direction here. What is the common denominator between this? Let's look at the numbers first. What is the common denominator between 3, 4, and 3? It's common multiple. 12. You can list that out, or you just multiply 3 times 4. They don't share any factors, so the common denominator is 12. What other factor do I need in my common denominator? I need an x. Okay, I see an x in each of those terms, so I need an x. So 12x is the common denominator. That's hopefully what you're working with, or if you didn't know that, hopefully that's what you're working with now. All right, I'm going to multiply each of the terms by 12x. That's the common denominator. So the first one, I've got 12x. I'm going to put it over 1. The second one, I've got 12x. I'm going to put it over 1. The third one, I've got 12x. I'm going to put it over 1. Multiply each of the terms by the common denominator, 12x. So in the first one, let's go bit by bit. I've got 12x here. I've got a 3x in the denominator. What cancels here? Hey, the x cancels. Good. We'll get rid of the x's. 1 you don't need to cancel because 1 divided by 1 is still just 1. But that's a good thought. They are the same. But 1 divided by 1 is just 1. But there is something else we can cancel. How many times does 3 go into 12? 4 times. 3 goes into 3 1 time. 3 goes into 12 4 times. And so I have 4 times 1 or 4. Minus. The second term right here. I've got 3 over 4x times 12x over 1. So again, I think we'll all say that the x's cancel. But what else cancels on this one? 4 goes into 12 3 times. That's true. So 4 goes into 4 once. 4 goes into 12 3 times. That is great. And so then what is left over is 3 times 3 in the top, and 3 times 3 is 9. On the other side, I've got 1/3 times 12x over 1. What cancels there? Yep, 3 goes into 3 once, 3 goes into 12 4 times. That's why we pick the common denominator. Okay, if you take the common denominator, everything in your denominator will cancel with something in what you multiply by. So when I do that now, I have 1 times 4x, which is 4x. There's my equation. No more fractions. The fractions are gone. I don't have them anymore. So now I can collect these like terms. 4 minus 9 is -5. I'm going to divide both sides by 4. And I've got a -5 divided by a +4. That's just a -5 over 4. Or if you love decimals, -1.25. Either way, now I'm going to just put that in some squigglies. That's my solution set. And I'm good to go. We're going to try another one. Same sort of thing. You're going to do the same thing every time on these problems. You're going to find the common denominator. Then you're going to multiply each term by that common denominator. Here's the next problem to try. We've got -3 over 20 plus 2 over x is equal to 5 over 4x. So first, identify the common denominator. And then when you've got that, you can go ahead and solve the equation. Common denominator. Let's look at the numbers first. I've got 20, I've got 4. What's the common denominator, least common denominator between 20 and 4? 20. So you could use, I mean, some of you might have said, hey, 20 times 4 is 80. You can use 80. You just got larger numbers to work with, but it'll get you to the same destination. Okay, remember listing method? Okay, if you struggle with that, you list the multiples out. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and that's the same thing as you'll have right here. That's how we know that the common denominator is 20. Listing method, I'll mention it again if I don't have a whole lot of time to spend on finding common denominators or common multiples between numbers. If you're struggling with that, talk to me outside of class. I've got videos I can send you. I've got extra help that I can make available to you. So 20, what other factor do I need in my common denominator aside from the 20? I need an x. Okay, I need that variable. Okay, so I'm going to multiply each of these terms by 20x. Okay, so let's see how it goes. I'm going to multiply each of these by 20x. So first fraction, I've got negative 3 over 20 times 20x. What cancels? The 20. It's staring you right in the face. Yes, 20 and 20. Leaves negative 3 times x, so that is negative 3x. Okay? Plus the next one. I've got 2 over x times 20x. What cancels there? The x does. I've got an x here, I've got an x there. Just cancel it. And so 2 times 20 is 40 equals 5 over 4x times 20x. What cancels? Okay, the x's cancel, and then 4 goes into 20. How many times does 4 go into 20? 5 times, yes. Your calculator can tell you that. Don't be shy, use your calculator. And so then what's left is 5 times 5, that is 25. Again, at this point, this should be the familiar point. I'm hoping that from here on out, that's not too much of a struggle. I understand this is difficult. That's why we're doing a bunch of problems, is to try to make this more palatable. Okay, so I've got a couple more of this type that have a monomial in the denominator. And so we're just going to keep practicing. So from here on out, what do I do first to solve this equation?
Minus 40.
Sure, minus 40. Perfect. So I've got negative 3x. The 40s cancel. I bring my equal sign down. 25 minus 40, your calculator will tell you that's negative 15. And then the last step to this is to divide by the negative 3. And you get x is negative divided by negative is positive 5. There's my solution set. All right, try this problem right here. It's the same sort of thing. I've got x, and then plus 15 over x is equal to negative 8. So first thing you're going to do is find the common denominator. Which shouldn't be too bad. There's only one denominator. And then you're going to multiply that by every term. Fraction or not, you multiply it by every term. Just so we're all working in the same direction. What's the common denominator of this right here? It's the only denominator, so it has to be the common one. Common denominator is x. That's it. So now, if you haven't done it yet, or you're wondering about that, you're going to take this x and you're going to multiply it by each of these three terms. And then solve the equation. It's going to be fun. It's going to be a blast from the past. All right, so this first term right here, this is not a fraction. So nothing's going to cancel. What's x times x? What does that give you? X squared for sure. Plus, here I've got an x in the top, I've got an x in the bottom, and so I have 15. And then over here I have negative 8 times x, so that's negative 8x. Okay, you cancel when you have fractions, and when you don't, you just multiply the things together. At this point, I've got x squared. I've got a quadratic equation. Okay, so this is the last unit. So we're bringing this back again. So to solve a quadratic equation, I have to get everything on the same side, and then I have to factor. Brought this back because I wanted to review it. There's a final exam coming up in 5 weeks, maybe 4.5 weeks. I forget the calendar, but it's coming up soon. There's going to be quadratic equations on the final exam. So what I'm going to have to do is I'm going to have to add this 8x to both sides. Everything's got to be on the same side for a quadratic equation. This 8x is not like terms with anything, so I can't add them together. So I'm just going to put them in line here. X squared plus 8x plus 15 equals negative 8x plus 8x is 0. This is a quadratic equation. The only way you know how to do this at this point in your intermediate algebra life in this class is by factoring. X squared, the only two options for x squared are x and x. This plus 15 tells me my signs have to be the same. This tells me they're going to be positive. And what are the two factors of 15 that are going to add up to 8? Sure, 3 and 5 or 5 and 3. The order absolutely does not matter. So then to revisit this, in case this had slipped your mind, now I have two unknown numbers equals 0 when I multiply them. So what that means is I can separate them and say, okay, one of these numbers has to be 0. So in this case, if it's the x plus 3, that means that the value of x would be negative 3. If you plug negative 3 in and anywhere, you're going to get a true statement. If it's this one, x is negative 5. This problem has two answers. Has negative 3 as an answer, has negative 5 as an answer. So here's my solution set. Quadratic equation. I've got one more problem for us to do that have a monomial in the bottom. Okay, same exact thing we've been doing, just different numbers, just so that you can run through this process and get it out in the open and ask whatever questions you need to. And then we're going to go on to the other type of problem that you're going to see when you do your homework and when you take your test and everything else. So here is this problem. I've got 2 over 3x is equal to 6 over 5x plus 8 over 45. common denominator. Let's look at the numbers first. 3 and 5 and 45. What is the multiple that 3 and 5 and 45 all have in common?
45.
And then we also need an x. So 45x is the common denominator. All right, I'm going to multiply each of these by 45x. So in this first fraction, x's cancel. Goodbye, x's. 3 goes into 45. That's going to leave me 15 when your calculator tells you the result. Okay, 45 divided by 3 ends up being 15. What's left? 15 times 2 is 30. Over here, the x's cancel. 5 goes into 45. 5 goes into 45 and leaves 9. 9 times 5 is 45. And so then what's left? I've got 9 times 6. 9 times 6 is 54. Plus, this last one, the 45's cancel. That's a relief. And what's left is 8 times x. 8x. There is my result. So now I'm going to solve this. I've got to get my x's by themselves. So I'm going to subtract 54. 30 minus 54, your calculator will tell you that's negative 24 equals 8x. Divide. Negative 24 divided by positive 8, and negative divided by positive is negative 3. And there we go. There's my solution set. All right, that's the problems that have a monomial in the bottom. Finding the least common denominator. Doing that. The other type of problem that you will see in this class, on your homework, on your test, there is problems that have other things in the denominator effect. So here's the example I wrote on the board of what a rational equation was. Looks like this: 2 over x minus 3 minus 3 over x plus 3 is equal to 12 over x squared minus 9. So we're back to this problem that was part of the introduction. All right, just giving you a moment to write this down. I know there's a lot going on here. So first thing I have to do is the first thing we did in all the other problems. I have to find the common denominator. There's one issue. Not really an issue, but there's one thing I have to contend with. X minus 3, that's fine. There's nothing I can do with that. X plus 3, that's fine. Nothing I can do with that. X squared minus 9. What do I have to do with that before I can figure out the common denominator? Got to factor it. Yeah, same thing we encountered in the previous section. So I'm going to rewrite this problem, and I'm going to factor the x squared minus 9. So I've got 2 over x minus 3 minus 3 over x plus 3 is equal 12 over, and x squared minus 9 is a difference of squares. It was one of the popular things we had to factor in chapter 5. So x squared minus 9. X squared is x and x. 9 is 3 and 3 plus 1 minus the other. There we go. Now we're ready. This, if you did the homework from section 6.3, the section on adding and subtracting, then I don't think this common denominator is too challenging. What is the least common denominator of these 3 fractions right here? I need an x minus 3, that's for sure. I need an x plus 3. You need one of every factor you see. If there's powers, you take the highest power. There's no powers here. I just need one of every factor I see. I've got an x minus 3 here. I've also got it here. Great. I've got an x plus 3 here. I've also got it here. Great. I need one of each. At this point now, I'm just going to multiply everything by that common denominator. So I'm going to multiply my first term by x minus 3, x plus 3. I'm going to put it over 1 so I don't do the wrong thing. I got to squeeze it in right here, x minus 3 times x plus 3. I'm going to put it over 1 so I don't multiply the wrong thing. And then the same thing over here. I've got x minus 3, x plus 3. I'm going to put it over 1 so I don't multiply it. I know it's a lot of writing, but please write it every time. It's going to be handy that I can just cross things out and I'll know exactly what's left over. So I know it's a lot of writing, so I'm giving you a moment to catch up with me. All right, so the first term. In the first term, my x minus 3s are going to cancel. See you later. I've got 1 in the top, 1 in the bottom. Great, no more fraction. That's what I wanted. So 2 times x plus 3, I got to distribute. 2 times x is 2x. 2 times 3 is plus 6. No more fraction. We're good to go. The next one, I've got 3 over x plus 3 times x minus 3x plus 3. What's going to cancel there? The x plus 3 is due. And so now I have this negative right here. So I have negative 3 times x minus 3. So negative 3 times x is negative 3x. Negative 3 times negative 3 plus 9. On the other side, it's going to be way more satisfying. I've got an x plus 3 and an x minus 3 in the bottom. I've got the same thing that I'm multiplying by. So the good news here is that everything's going to cancel. The x plus 3's go away. The x minus 3's go away. And I'm left with 12. No more fractions. It's what I wanted. It's what makes me happy. So the rest of this, I'm going to collect my like terms. And I'm going to solve. I've got 2x minus 3x. That's negative x. 6 plus 9, that's 15. I'm going to subtract the 15 from both sides. And I've got negative x is equal to negative 3. And then last but not least, I divide by negative 1. And I get that the x value is 3. I'm going to pause here, let you catch up. So there was something earlier I said, we'll have one more thing to consider when we find our answers to these problems. Doesn't happen too often with the monomial type problems, but it has happened here. It's something we have to be aware of. When we got to this chapter, the very first thing, if you flip back in your notes, the very first thing we talked about in this chapter was the domain of a rational expression. Remind me, in case that word still isn't familiar to you. Domain, what does domain refer to? The x values I can use. And there was one problem. You cannot have 0 in the denominator of a fraction. You can't divide by 0. So what we have to make sure is we always have to make sure that our answer doesn't make a denominator 0. So I'm going to make this little note for you so that when you're looking back over later, when you're reviewing your notes, you remember what's going on here. We always have to check to be sure, the answer does not, I'm going to underline that because that's what we do not want, does not make 0 in a denominator. It hasn't happened up till now. That's why I haven't mentioned it. I figured solving was enough of a challenge for our first problems, but this is my example of where it does happen. So notice, when I take the x value 3, and I plug it in right here, what's 3 minus 3? What does that make? 0. Okay, that's a problem. Can't have 0 in the denominator. So because of that, on this problem, it doesn't always happen. Sometimes you keep your answers, sometimes you have to throw them out. It just depends on the numbers. I have to throw this one out. It makes this denominator 2. It makes this one 6, but that doesn't matter. It makes this one 0, so I throw it out. So my answer to this problem, my solution set on this one is the empty set. There's no answer to this. The only possible value that I got made 0 in a denominator. We can't divide by 0. Numerically, it's impossible. So my set is the empty set. So we're going to do a few problems like this that have binomials. Some of them you might throw the answer out. Others you're going to keep it. It just depends on the problem. I think I've thrown in a little bit of everything into this. So here's yours. First one, I've got several. So your problem is this. You've got 1 over x minus 7 plus 2 over x plus 7 equals 14 over x squared minus 49. So what I'm going to do is I'm going to give you a couple minutes to figure out what the common denominator is. If you want to stop there, great. But if you feel greatly confident, then keep going, and we'll compare notes at the end. In order to figure out the common denominator, I'm going to factor this last one. So I'm going to write that down. So keep working. So this denominator, x squared minus 49, it's a difference of squares. Factors to x plus 7, x minus 7. So from there, what is the least common denominator that I'm hoping you're using or hoping that you identified? What do you need? 100%. Great. I'll give you a couple more minutes in case you were stopped. So go ahead now, multiply everything by that common denominator. All right, I'm going to multiply each of these by x plus 7 and x minus 7, and we're going to see what happens and how this equation works out. So in the first one, the x minus 7s go away, that's fine, and I have 1 times x plus 7, which just becomes x plus 7. The next one, the x plus 7s cancel, and so I have 2 times x minus 7, so 2 times x is 2x, 2 times minus 7 is negative 14. The final one, both cancel, x plus 7s, x minus 7s, they both go away, and I'm left with 14. Solving this equation, linear equation, we did stuff very similar to this a while ago. X plus 2x is 3x, 7 minus 14 is negative 7. 2 steps to the finish line. First one is to add 7. 14 plus 7 is 21. Second step is to divide by 3, and I get x is 7. If you got there, you did a great job. It's beautiful work. But I wanted to make sure that you now have on your mind that we always have to check our answer, make sure it's in the domain. It doesn't make a denominator 0. Does this 7, does that make any of my denominators 0? Yes, it makes this one, 7 minus 7 would be 0. It also makes this one, 7 squared is 49 minus 49, 0. So we have to throw that one into the trash bin. And so my solution set here is the empty set. There's no x value that satisfies that equation. That won't happen every time. I just wanted to reinforce the previous mention. So let's try this one. See how you do with this next problem. Same sort of thing. We're practicing. We got a half hour. I've got 3 more problems like this for you, and then this is section 6.4. I think I misidentified it earlier. There's also solving in section 6.5. So we're gonna do some of the solving from there as well. It's the same sort of thing. It's not really any different. Just gonna try to use our time well. So here is your next problem. Let's say you have this. 3 over x minus 2 plus 21 over x squared minus 4 is equal to 14 over x plus 2. If you work and keep working, I'm just going to do the first step. I'm going to factor this denominator so that we can identify the least common denominator. So x squared minus 4 becomes x plus 2, x minus 2. Everything's been a difference of squares to keep things relaxed so far. And so that means that I can now identify my least common denominator of this problem. And the least common denominator is 1 of every factor you see. So I need an x minus 2, and I need an x plus 2. Keep working. If I interrupted you, or maybe I helped you, I don't know which. If you have a question, ask it. I'm just standing here, happy to do whatever I can to make sure that we can be successful here. All right, so I've got my x minus 2 and x plus 2 here times every term. Well, let's do it. So first term, the x minus 2 canceled with x minus 2. So I have 3 times x plus 2. So 3 times x is 3x. 3 times 2 is plus 6. Then here I've got x plus 2's and I've got x minus 2's. So I'm just left with 21. Everything cancels on that middle one. And here's my equal sign. And then the x plus 2's cancel here. And I have 14 times x minus 2. 14 times x is 14x. 14 times negative 2 is negative 28. Ready to solve? I'm going to collect these like terms. So I have 3x, 6, and 21 is 27. And then I have 14x minus 28. I'm going to get all of my x's on the left. That's what I like to do. Put all my numbers on the right. And then we'll see how it goes. So x is on the left. I'm going to subtract the 14x. I'm going to transfer the problem over to the top so that everybody can see it. So I have 3x minus 14x is negative 11x. Then I have plus 27 equals, and on the other side, the 14's cancel, I have negative 28. There we go. So I've got all my x's on the left. That's what I like. I'm going to put all the numbers on the right. So I'm going to subtract 27 from both sides. So that leaves me negative 11x. The 27's cancel. Negative 28, negative 27 is negative 55. And last but not least, I'm going to divide. That's always my last step when I'm solving my linear equations. And I have x is equal to negative 55 divided by negative 11. A negative divided by a negative is positive 5. Final question. Does that make any of my denominators 0? Doesn't make this one 5 minus 2 is 3. Great. Doesn't make this one 25 minus 4 is going to be 21. And then 5 plus 2 is 7. So great. Finally, we got one that works. That's happiness. There it is. My solution is 5. Okay. So here is the second to last problem from this section. This is a fun problem. It's a fun problem of the day. So you're going to have some factoring to do to figure out the common denominator on this one. but I know you can do this. So here we go. We've got 2 over x squared minus 2x minus 8 minus 4 over x squared plus 6x plus 8 is equal to 2 over x squared minus 16. So you got 3 things to factor. That's fantastic. And then figure out the common denominator. If you feel good about that, keep going. If you want to wait for me, I will help verify that you got the right common denominator. I'm just going to start factoring, so keep working. I don't want to distract you. I'm going to begin the factoring process here. My x squared minus 2x minus 8, x squared is x and x. The negative 8 tells me my signs have to be different. And the 2 factors of 8 that are going to make everything add up to negative 2 are going to be negative 4 and plus 2. Similar thing here in the middle. I've got x squared is x and x. The 8 tells me my signs are the same. The 6 tells me they're both going to be positive. And the 2 factors of 8 that add up to 6 are 4 and 2. Last but not least, I've got a difference of squares because we seem to have one in every problem. So x squared minus 16. And so that is x plus 4, x minus 4. So help me identify the common denominator, and then I'm going to give you more time to do this problem. So my least common denominator for this problem, what factors do I need here? That is true. Yep, one of everything. That's it. I like finding common denominators of these because they just take one of everything you see and you're good to go. So there's 3 things. So you're going to go through, you're going to cancel all those fractions if you haven't done it already, and then you're going to solve what's left. Yes. So the first fraction, so we're multiplying each of these by x plus 2, x minus 4, x plus 4, x plus 2, x minus 4, x plus 4, plus 2 minus 4, plus 4. That's the common denominator. So hopefully, if we've chosen well, which we have, every one of these fractions is going to go away. So here goes. The first one, the x plus 2's cancel with each other. The x minus 4's cancel with each other. And so I'm left with 2 times x plus 4. 2 times x is 2x. 2 times plus 4 is plus 8. Next, I have x plus 4, x plus 2 in the denominator. So the x plus 4's cancel. The x plus 2's cancel. And I have negative 4 times x minus 4. So negative 4 times x is negative 4x. Negative 4 times negative 4 is plus 16. On the other side, here's my equal sign. I've got the x plus 4, x minus 4. So the x plus 4's go. The x minus 4's go. And I have 2 times x plus 2. So 2 times x is 2x. 2 times 2 is 4. So this looks a little nicer. Your fraction, ready. Like terms, 2x minus 4x is negative 2x. 8 and 16 is 24. On the other side, I've got 2x plus 4. I'm going to get all of my x's on one side. I'm going to get all of my numbers on the other side so that I can divide. I like to put my x's on the left. That's not what you have to do. I'm going to bring the equation up to the top. So negative 2x and negative 2x is negative 4x. Then I've got plus 24. Then I've got equals. And on the other side, I've got 4. All of my x's are now on the left where I want them. I'm going to put all the numbers on the right. So this is a plus 24. I'm going to subtract it. 4 minus 24 is negative 20. Divide, it's always the last step. And I end up with x is negative divided by negative. 20 divided by 4 is positive 5. I look back with that positive 5. Does positive 5 make anything at all 0? It makes this one 7. It makes 5 minus 4 is 1. 5 plus 4 is 9. 5 plus 2 is 7. 5 plus 4 is 9. 5 minus 4 is 1. No, it makes nothing 0. Everything is good. So there's my solution, 5. All right, one more problem for you from this section. So we'll see how much time that eats up, and we'll see if we just hold off on the rest on 6.5. And 6.6 is a real short section. We'll finish that up next week on Monday and get you ready for your second to last test in this class. So here is my last problem for you. From this section, I've got 2x over x minus 2 is equal to negative 3 over x plus 4 over x minus 2. The nice part about this problem is there's no factoring. At least no factoring to find your common denominator. You might have to factor to solve. Just to get us all going in the same direction, what's the least common denominator of this problem? I need x minus 2 and an x. You need both. I know there's an x in the x minus 2, but remember, this x is attached to the minus 2. They go together. And this one's all alone, so they're different things. Okay, common mistake. That's why we're doing this problem. One of the reasons we're doing this problem is to make sure that we can differentiate between those two things. All right, so I'm going to take each of these times x minus 2. We're going to get to the second part of the problem, and the reason I chose this problem was twofold. The first, I already told you, to make sure that we can differentiate that x and x minus 2 are different factors. The second reason I chose this problem is we're going to end up with a quadratic equation. And I want to just make sure we're keeping that fresh because it's not going to go away. So here goes. The first one, the x minus 2's cancel. So I have x times 2x. That's 2x squared. So not only do we have a quadratic equation, we've got one with a number in front of the x squared. Okay, so we're going to have to revisit that. Here the x's cancel, so I have negative 3 times x minus 2, so that's negative 3 times x is negative 3x. Negative 3 times negative 2 is plus 6. And then lastly, I have the x minus 2's cancel, and I have 4 times x. Let me collect those like terms on the right, and then we'll talk about solving this. So I have negative 3x plus 4x, that's plus 1x, and then plus 6. This square here tells you this is a quadratic equation. Okay, I have to deal with this differently than I've dealt with other equations, linear equations. What this tells you is I have to get everything on the same side. It has to be equal to 0. There's no choice. Okay, so this hopefully in one sense is a review, but I know that sometimes these things slip our minds. So I'm going to get everything on the same side of the equation. I'm going to bring the equation up to the top because I'm going to need some room. So I've got 2x squared. Then I've got minus x. Then minus 6. And since I took everything away from the right side of the equation, I'm left with 0 on the right side of the equation. Okay, so it's been a while. It's been a few class periods since we've factored something that has a number in front of the squared. Anybody remind me what's my first step that I do when I have a number in front of the squared to factor this? You multiply the number in front of the square times this number on the end. It's called the AC method or the grouping method that we're going to employ here to do this. So 2 times negative 6 is negative 12. Then my thought process becomes the same as my thought process when I'm factoring something with a 1 in front of the squared. I need the 2 factors of negative 12 that are going to add up to this middle number. Because this is a negative 12, my values are going to be positive and a negative, or negative and positive. The order doesn't matter. And what are the factors of 12 that are going to be 1 apart? 3 and 4. And I'm going to make the 4 the negative 1 because they have to add up to a negative 1. Okay, good. What do I do with these numbers? Why did I get them? How do they help me? That's the middle number. Yeah, I'm going to use these two things for that one. I'm going to make a 2-for-1 exchange. So the 2x squared does not change. But what I do with these numbers is instead of having one middle term, I'm going to take these two things and have 2 middle terms that add up to the same thing. So I'm going to have plus 3x minus 4x. Okay, notice 3x minus 4x still adds up to negative 1x. Okay, so I've not changed the problem at all. I just changed the structure of it a little bit. And so then minus 6 equals 0. In fact, I'm going to leave the equal to 0 off until we factored it. Then we'll bring it back. Let's just concentrate on the factoring. Now that I have this separated, instead of 3 terms, it's 4 terms. And what is the factoring method that I can employ when I have 4 terms? Grouping. Grouping means I group the first 2 terms and consider only those, and I group the last 2 terms and I consider only those. What is common to the first 2 terms? What can I factor out of that? True? When I factor an x out, I started with 2 times x squared. I factored one of the x's out, so that leaves me 2 and one of the x's. I started with 3x. I factored the x out. That leaves me plus 3. What can I factor out of the second pair of terms, the negative 4x and the negative 6? A negative, sure. And anything else? 2. They're both even numbers. I can factor out a negative 2. So a negative 4 divided by a negative 2, a negative divided by a negative leaves positive 2x. That's good because I have a positive 2x over here. Negative 6 divided by negative 2, negative divided by negative leaves plus 3. So that's good. Since it's been a while, I'm just going to ask you this question. Same questions I've asked you before. How do I know if the grouping has worked or not? They match. Well said. I like that word. These 2 things match up. You know the grouping has worked. So 2x plus 3 here, 2x plus 3 here, the grouping has worked. So I can factor that out. When I factor the 2x plus 3 out of the first term, I have x. When I factor the 2x plus 3 out of the second, I have a minus 2. And now I'm going to bring back my equal to 0 because it's an equation I'm solving. So to finish this now from now on, it's just like the other quadratic we did earlier in the class. I'm going to set both of these things equal to 0. This first one, I subtract 3 from both sides, and I get 2x equals negative 3. Divide by 2 on both sides, and I get that my first possible solution is negative 3/2, or negative 1.5. Over here, I add 2, and I get my second possible thing is x equals 2. Lots of work. This is the hardest problem by far that we did today. Before we get happy though and say these are both my answers, let's make sure we check and make sure they don't make any denominators 0. Let's try the 2 first. How about the 2? Does the 2 make any of my denominators 0? Yeah, it makes first one, last one. 2 minus 2 is 0. Sorry, goodbye, throw you out. Negative 1.5 or negative 3/2. Does negative 1.5 make any of my denominators 0?
No.
No. Pop out your calculator. Negative 1.5 minus 2 is negative 3.5. That's fine. This is just x. That's negative 1.5. So that's not 0. So that works out just fine. So I like it. And so my solution set is negative 3/2. Like I said, sometimes you're going to keep the answer. Sometimes you're going to throw them away. Just depends on the problem. This one, we did one of each. Other problems, you could keep both of them. Okay, you can have more than one. All right, so we are going to call it a day.